In this video, I will show you how to graph the dilation of an image based on a given scale factor. For this video, we're going to stick to dilating using the origin as the center of dilation. In future videos, I'll show you how to do it from different points. So when you're doing a dilation, you're basically either doing an enlargement or you're shrinking the image smaller, but the shape should remain the same when we're done. The first step is to record the original points. So for example, point D is the point -3, -3. Point E is -3, +3. Point F is 2, 3. And point G is 2, 0. So the scale factor for this problem, we're going to do our dilation with a scale factor of 3. So all you have to do is multiply all of these by 3. So as I'm finding the image of each one of these points, because the scale factor is 3, I'm just going to multiply the x value and the y value by 3. So that's why D prime is going to be -9, -9. And E prime will be -9, +9. F prime will be 6, 9. And G prime will be 6, 0. Just simply multiplied everything by 3. So now I'm just going to plot these points. So -9, -9. I should count and make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what I thought. So -9, -9 will be right here, D prime. -9, +9. So there's my E prime. 6, 9. 6. So that'll be F prime. And 6, 0. And that'll be G prime. And that's basically how you do it. I'm just going to go ahead and connect the dots here. Whoa, that is not the ink that I was looking for. Let me try that again. All right, so that is how you do a dilation from the origin. Let's practice that again with problem number 2. Okay, so point L is the point 4, 8. And point M is 4, -4. And then N is -4, 0. All right, so we need to do this dilation. This time the scale factor is 5/4. So in each case, I need to multiply the x value and the y value by 5/4. So I'm multiplying by 5/4. Now, notice that this number is bigger than 1. I can tell because the larger number is in the numerator. So this should still be an enlargement. It should be getting a little bit bigger. I'm going to do a couple calculations off to the side so you can see where I'm getting my results. So so this will be L prime. So if I want to do 4 times 5/4, all right, so 4 times 5/4, the easiest thing to do is realize that these 4's will cancel each other out. So you will just get 5. If I want to do 8 times 5/4, so 8 times 5/4, the easiest thing to do is to divide 4 into 8. That goes twice. And then 2 times 5 is 10. All right, now if that was at all hard to follow, you could use your calculator and you could do 8 times 5/4, and you could get your 10 that way. So if I do any of these calculations, for me it's quicker to do this than it is to even type it into a calculator. But some students have trouble following this, so you can always use a calculator. So let's go ahead and find M prime. So we already did 4, so we know that that was going to be 5. And so, of course, -4 will just give us -5. And here's another -4. So that'll be another -5. And 0 times anything is still 0. So let's plot these points. 5, 10 is going to be right here. There's L prime. 5, -5 is right there. M prime. And then -5, 0. N prime. So you can see this triangle is going to just be a tiny bit bigger than the original. All right, I really meant for this to be purple. All right, so there you go. Another example of a dilation. All right, so now it's time to calculate a scale factor that will turn image A, well, the original, the pre-image, into the image. So you can tell that the rectangle on the left is the original, right? It's the pre-image because it does not have a prime on it. So this is basically the old shape, and this is the new shape. I think I'm going to color coordinate this a little bit. So we have the old shape and the new shape, the pre-image and the image. Now, when you want to find the scale factor, which I'm just going to abbreviate SF for scale factor, the scale factor is going to be a new length divided by an old length. All right, so in this case, if I want to calculate the scale factor, I just need to pick one of the sides and compare. So for example, let's do the height of the rectangle. The new rectangle has a height of 4 compared to the old rectangle that has a height of 2. So that means that the scale factor is going to be 4 over 2. It's going to be new over old. So of course that means that the scale factor is going to be 2. All right, that's all there is to it. That's super easy. So looking at problem number 4, All right, so if I want to find the scale factor, I need to do new over old. So let's just use the base of this triangle. So the new, it has a base of 2, whereas the old has a base of 3. So if I do new over old, that's going to be 2 over 3. So that would be the scale factor for problem number 4. Okay, find the scale factor for each dilation. So let's just keep it going. The scale factor, like we said before, is going to be new over old. So we can just pick either the x value or the y value. I'm going to use the numbers that seem smaller. So it really doesn't matter, but I'm going to pick the 6 and the 10. Remember that the prime is the new, and the regular letter is going to be the old, all right, the pre-image and the image. So if I do new over old, that's going to be 10 over 6. We're supposed to do reduced fractions, so this will be 5 over 3. So that would be the scale factor for part A. Moving on to part B, just doing the same thing, scale factor, still doing new over old. Okay, I think I'll use the y values this time. So this would be negative 15 over negative 12. So that's going to be positive. Both of these are divisible by 3, so that's what I'm doing. So that's going to give me 5 over 4, positive 5 over 4. All right, and moving on to part C. Okay, still doing new over old. So this time they didn't give us a letter and a prime. They just told us that ABC turns into DEF. So that means that ABC is the original and the DEF is the new one. Okay? Now you have to be a little bit careful. You have to make sure you're doing corresponding sides. So for example, pay attention to the fact that AB corresponds to DE because of the order of the letters, right? They have to be in the same position. So here's AB right here, and here is DE. So just make sure you carefully look at the letters so you can see which numbers correspond. Because obviously if you try to match the 6 with the 12, you're going to get the wrong answer. Okay, so really this is enough for us to go ahead and do the scale factor. Okay, so remember that the DEF is the new and the ABC is the old. So for the scale factor, we always do new over old. So we will do 8 over 6, which reduces down to 4 over 3. All right, so it looks like we're doing the same exact picture, but this time we're finding the scale factor that turns DEF into ABC. So this time DEF is the old and ABC is the new. All right, so this is the old and this is the new. All right, we already talked about the fact that these two sides are corresponding, but obviously when we go to do the scale factor, you can probably guess that it's just going to be the reciprocal of this. because we're doing the same two numbers. But when we do new over old, this time we're going to do 6 over 8 instead of 8 over 6. So that's going to give us 3 over 4. So if all they do is reverse which one is new and which one is old, that just causes the scale factor to be the reciprocal of whatever it was. It's just going to be upside down. Okay, so these two triangles are similar. These two rectangles are similar. This is the symbol for similarity. We need to find the scale factor that turned ABCD into EFGH. So when they give us a statement like that, they're telling us that this one is the old and this one is the new. Okay, so this one is old and this one is new. So if I want to find the scale factor, I know that the scale factor is always going to be new over old. Okay, so just make sure you're using your corresponding sides. Okay, so new over old. Let's focus in on the 30 and the 75 are obviously corresponding. Okay, the 80, we don't have whatever number matches with 80. We don't know what that is yet. But we have the 30 and the 75, so let's use that. Okay, so new over old is going to be 75 over 30. Okay, we just need to reduce this. Let's use the calculator. Okay, 75 over 30, so 75 over 30. That's going to be 5 halves. Okay, so that is the scale factor. Now apply this scale factor to find the length of HG. Okay, so the length of HG is right here, like X. So remember, if you want to turn an old length into a new length, all you have to do is multiply by the scale factor. So the old is 80. So if I take the 80 and I multiply it by the scale factor, multiply it by 5 over 2, that should give me the new length, right? Just multiply by the scale factor and you get the new length. So whatever 5 over 2 times 80 is, and I can tell what that's going to be. 200. Okay, but let's do it. 5 over 2 times 80. Okay, so the length of HG is going to be 200.